Hello everyone! Welcome to my virtual classroom. This is Mathematics 5. We are now on quarter 2, week 8. And this is your teacher, Ma'am Bell. Our topic for today is about equivalent ratio. Ratios are used to compare numbers. When you're working with ratios, it's sometimes easier to work with an equivalent ratio. Equivalent ratios have different numbers but represent the same relationship. In this video, you'll see how to find equivalent ratios by first writing the given ratio as a fraction. Okay? So take a look at this and let's start. Okay, so ratios are everywhere. Common examples of ratio include comparing prices per item while grocery shopping, calculating the proper amounts for ingredients and recipes in baking or cooking. And when you are having a vacation trip, you need to determine how long our trip might take. Okay? So, what do you mean by ratio? Ratio means it is the comparison of two numbers or quantities. There are three ways in writing a ratio. The most common way to write a ratio is a fraction. Example, 3/4 or 3/4. We could also write ratio using the word. The word is to. Okay, this is called word form. So 3:4. And finally, we could also write this ratio using a colon between the two numbers. We call it colon form. So 3:4. Okay, be sure you understand that these are all ways to write the same number. So, three ways in writing ratio. We have fraction form, word form, and colon form. Okay? Let's have an example for ratio. Write ratios using a colon or fraction form. I have here a set of fruits. We have bananas and apples. So, how many bananas and how many apples that we are going to compare? There are 12 bananas, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 bananas, and there are 5 apples. So the ratio of bananas to apples is 12:5. That is in colon form. And then in fraction form, it is 12/5. Example number 2. Okay, we have red dots and blue dots. Okay, we're going to compare the number of red dots to the number of blue dots. So, how many red dots? We have 1, 2, 3, 4, 5, 6, and the blue dots, we have 4. 1, 2, 3, 4. So, what is the ratio of the red dots to the blue dots? That becomes 6:4. But since 6 and 4 has a common factor, which is 2, then we are going to simplify our answer. So, 6 divided by 2, we have 3, okay? 1, 2, 3. We have 3. And then 4 divided by 2, we have 2. 1, 2. So, the answer, our final answer is 3:2. And in fraction form, we have 3/2. Okay? Okay, number 3 example, we have squares and diamonds. So we are going to compare the number of squares to the number of diamonds. So how many squares? We have 5, 10, 15 squares. And what about the diamonds? We have 5, 10, 15, 20 diamonds. Okay, so we are going to compare the number of squares to the number of diamonds. So, 15 squares to 20 diamonds. So, since 15 and 20 has a common factor, which is 5, then we need to simplify our answer because ratio can also be simplified like fraction. Okay? So, 15 divided by 5, we have 3, which is 1, 2, 3. And 20 divided by 5 is 4. So, we have 1, 2, 3, 4. So therefore, our answer becomes 3:4. Okay, that is in column form, and then in fraction form we have 3/4. So again, what is a ratio? Ratio is used to compare the number of objects in two or more groups. Okay, I'm going to show you a picture. Okay, a group of children. So what do you think? The objects that we're going to compare are the quantities. We're going to compare the number of girls to the number of boys. Okay, so how many are girls? There are 2 girls, 1 and 2. Okay? And how many are boys? We have 3. 1, 2, 3. So there are 3 boys. And what do you think will be the question for this one? The ratio of, what is the ratio of girls to boys? Okay, so what will be your answer to that question? What is the ratio of girls to boys? Your answer will be, the ratio of girls to boys is 2:3. And what about boys to girls? What is the ratio of boys to girls? The ratio of boys to girls is 3:2. Okay? Very good. And these are the things that you need to remember. The order in ratios is important. And ratios are not the same as fractions, but they are similar. And we can have equivalent ratios just like we have equivalent fractions. Okay, let's try to have this example, equivalent fractions. Are the fractions below equivalent, 1/4 and 3/12? How are we going to know if these two fractions are equal? We are going to use the cross multiplication method. Very good. So we will cross multiply 1/4 and 3/12. When you say cross multiply, we need to multiply the numerator by the denominator of the other fraction. So this becomes what? 1 times 12. The product is 12. And we have 3 times 4. The product is also 12. So look at their products. They have the same product. Meaning, the fractions are equivalent. Okay, so what about equivalent ratio? Okay, so write 2 more equivalent ratios for the ratio given. I'm going to show you a picture. This is a picture of a teacher and pupils. So, what is the ratio of teacher to pupils? We have 1 teacher to 4 pupils. So 1:4. And I'm going to add another picture, the same picture as the first one. So how many teachers are there in all now? We have 2. 1, 2. What about the pupils? We have 4 plus 4 is 8. The total of 8. So our new ratio is 2:8. That's correct. Okay? 2 teachers and 8 pupils. And then I add another one picture. So how many teachers are there in all? We have 3. 1, 2, and 3 teachers. What about the pupils? We have 4, 8, 12. So therefore, the ratios of teachers to pupils is how many? Or what is the answer? 3:what? 12. Okay? So 1:4 is equal to 2:8 is equal to 3:12 are equivalent ratios. Okay? If you are going to change this one to lowest term, the 2 8s, this becomes 1/4. If you are going to change 3:12 to its simplest form, it becomes 1:4. Okay? That is equivalent ratio. I have another example for this one. Okay, groups of fruits. We have cherries, bananas, and oranges. So what is the ratio of cherry to banana to orange? How many cherries? We have 2 cherries. Okay? And 4 bananas and 3 oranges. And what if I add another 1 picture like that? How many cherries are there in all now? How many bananas? And how many oranges? Okay, so cherries have 4 and bananas have 8 and oranges have 6. So the ratio of cherry to banana to oranges is 4:8:6. And what if I add another 1 picture? How many cherries are there in all now? We have 6. And how about bananas? We have 12 bananas. And how many oranges? We have 9 oranges. Okay? So, what is the ratio of cherry to banana to orange? We have 6:12:9. Okay? So, again, 2:4:3 is equal to 4:8:6 is equal to 6:12:9. Okay? So, these 3 groups of ratios are equivalent ratios. Okay? Again, fraction and ratio. You can write ratio in fraction form. So, example 1/2. In ratio, it is 1:2. Okay? What about this one? 4/7. In fraction form, we have 4/7. And the ratio is 4:7. So, the following methods are used in finding the missing term in a pair of equivalent ratios. First method, we can use the cross multiplication, which I have already explained that one earlier in our earlier slides. So, we have 2 fractions, 15/3 and 5/1. Okay, so we'll just cross multiply 15 and 1. So, 15 times 1 is 15, and we also cross multiply 5 and 3, and the product is 15. So look at their products, 15 and 15. Therefore, they have the same product, and that becomes equivalent fraction or equivalent ratio. Okay. Another method is the multiplication of extremes and means. So, of course, we are going to write these 2 ratios in a proportion, okay, in a proportion, because extremes and means, these are terms used in proportion. These are the parts of proportion. So, we can also check if the 2 ratios are equal using this method, multiplication of extremes and means. So, what do you mean by extremes? Okay, so look at here, we have the extremes, the terms, the first and the fourth term are the extremes, this one. So get the product of 15 and 1, we have 15. And the product of the means, which is this one, 3 times 5, is also 15. So therefore, 15:3 is equal to 5:1. These 2 ratios are equal. Okay, so these are equivalent ratios because their products are equal. And to check if 2 ratios or 2 fractions are equivalent, use the cross multiplication process. The cross product must be equal. Okay, and the other method is getting the product of the extremes and the means. The product of the extremes must be equal to the product of the means. It's practice time. Okay, so you'll be given 1 minute to answer each question that will be posted. And then after 1 minute, we are going to show your answer on screen. Okay? So let's start with the first question. Are the ratios equivalent? 1:5 and 3:15. Your answer is just yes or a no. But you have to check first before you say yes or before you say no. Okay? And I'll give you 1 minute to answer this one. And timer starts now. Okay, time is up. Your answer is? Yes. Okay. Number 2. Are the ratios equivalent? 2:3 and 6:9. Timer starts now. Time is up. Okay, show me your answer. Your answer is? Yes. Next. Next is, are the ratios equivalent? Okay, 12:5 and 5:12. And timer starts now. Okay, time is up. And your answer is? No. Okay, next question. Are the ratios equivalent? 5:1 and 25:5. Timer starts now. Okay, time is up. And your answer is? Yes. Okay, last one. Are the ratios equivalent? 3:1 and 4:5. Timer starts now. Okay, time is up. And your answer is? Of course, no. Okay, so let's continue. Another one, write yes on the blank if the expression shows an equivalent ratio, no if not. Okay, and you'll have 5 minutes to answer these questions. Timer starts now. Okay, time is up. Okay, let's answer. Number 1 is yes. Number 2 is no. Number 3 is yes. Number 4 is no, yes. And the number 5 is no. Okay, so that's all for today, guys. Bye.